Amidst Turkey's ambitious ambitions for self-sufficiency in the defense industry, a strategic project emerged that has now become a symbol of the rise of national aerospace technology. The TAI Hürjet. This jet trainer aircraft was developed by Turkish Aerospace Industries as a new generation replacement for legacy jet trainers and a bridge to modern fighter aircraft. But behind its aerodynamic design and supersonic performance lies a long history of a giant factory, thousands of engineers, and a high-tech manufacturing process. All of this is centered at TAI's main facility in Ankara, Turkey's largest aerospace industrial complex. The production and assembly area at this facility includes a spacious hangar, a systems integration center, a structural testing laboratory, and a final assembly line. This is where the Hurjet is formed, from thousands of components into a single flight-ready aircraft. Before a single piece of metal is cut, the Hurjet is born in the digital world. Engineers use computer-aided design software and aerodynamic simulations to virtually test the aircraft's structure. Every wing curvature, air intake position, and cockpit layout are calculated to deliver optimal performance at high speeds. Once the design is validated, the manufacturing process begins. Key materials such as high-strength aluminum alloys and lightweight composites are processed in the fabrication facility. The fuselage structure is assembled in stages, using modern riveting and bonding techniques that ensure both strength and weight efficiency. On the initial assembly line, large sections such as the front, center, and rear fuselages are manufactured separately. The wings and tail are also assembled as individual modules. Each module undergoes rigorous quality inspection, using non-destructive scanning technology to detect potential microcracks or material defects. Once the major modules are ready, they move to the structural integration phase. This is where the fuselage begins to take on a complete shape. The wings are installed, the tail structure is connected, and the internal frames are reinforced. This process requires as even small errors can impact aerodynamic performance. The Hurjet features a sleek design with swept-wing wings and a single vertical tail, providing high stability and agile maneuverability. The fuselage structure utilizes lightweight yet strong composite materials, improving fuel efficiency and flight performance. The Hurjet is capable of flying at speeds up to Mach 1.4 supersonic. This makes it one of the most modern supersonic trainer jets in its class. Some of its performance capabilities include maximum speed, approximately 1,400 kilometers per hour, service ceiling, approximately 45,000 feet, high G-forces for combat maneuver training, powered by a turbofan engine with afterburner. One of the Hurjet's key features is its fully digital glass cockpit, equipped with a multifunction display MF, a head-up display HUD, a helmet-mounted display system and an advanced computer-based avionics system. This technology makes the training experience very similar to that of a modern fighter jet, increasing the effectiveness and efficiency of training. In addition to being a training jet, the Hurjet also has an armed variant that can carry air-to-air missiles, air-to-ground missiles, precision-guided bombs, rockets and cannon pods, with several hardpoints under the wings. The Hurjet is capable of carrying out missions, close air support, counterinsurgency coin. The next stage is the installation of the avionics system, electrical wiring, hydraulic systems, and flight controls. The Hurjet's cockpit is designed with a large digital display glass cockpit reminiscent of a modern fighter jet. The goal is to familiarize pilots with the digital combat environment from the training stage. Thousands of cables are installed in a structured layout. The control system is tested repeatedly to ensure every button, sensor, and indicator functions perfectly. The jet engine is installed in the final integration stage, followed by testing of the fuel and pressurization systems. Before the Hurjet is allowed to take to the air, it must undergo a series of ground tests. Vibration tests are conducted to simulate the stresses of flight. The engines are started for the first time in an engine run test, checking thrust stability and system response. The flight test is the most stressful and rewarding stage. Test pilots take the Hurjet into the air for the first time, verifying its real-world performance compared to simulations. Parameters such as stability, control, response, and engine performance are monitored in real time. After passing through various phases of flight testing and refinement, the aircraft is declared ready for further production. With its extensive facilities and experience from the prototype phase, TAI is now preparing the Hurjet for mass production. The production line is designed to meet both the needs of the Turkish Air Force and its export potential. The Hurjet is positioned not only as a training jet but can also be configured as a light attack aircraft. This flexibility increases its appeal in the international market, especially for countries seeking both training solutions and light combat capabilities at lower operating costs than heavy fighter jets. Behind each Hurjet are thousands of workers, from engineers and technicians to logistics staff. This program is driving the growth of the domestic supply chain, strengthening the local component industry, and enhancing technology transfer more than just a military project. The Hurjet symbolizes Turkey's industrial transformation. From a technology buyer, Turkey is now a developer and manufacturer of its own advanced jets. Behind the giant hangar doors and the roar of test engines, the Hurjet is built through a combination of strategic vision, technological sophistication, and collective hard work. Every bolt tightened and every cable installed is part of a grand dream: aerospace independence. The Hurjet is more than just a training aircraft. It is proof that behind Turkey's largest factory, the future of national aviation is being assembled piece by piece, with precision and pride. Precision and pride.